Let's go over our solutions to linear equation exercises. So when we solve linear equations, what we want to do is isolate the variable. So get the variable completely by itself. And then you can always check by plugging in your solution back into the original equation that you have and make sure you get a true statement. So for this first example, 2 times 5x minus 4 equals negative 3 times 7 minus 2x. So what we want to do is isolate the variable. We want to solve for x. So the first thing we'll need to do is distribute the 2 and distribute the negative 3. And when we do that, we have 10x minus 8 equals negative 21 plus 6x. So now what we can do is we can add 8 to both sides. And when we do, we get 10x equals negative 13 plus 6x. And now we'll need to bring this 6x over here to the 10x by subtracting 6x from both sides. And we get 4x equals negative 13. Divide both sides by 4 and we get x equals negative 13 fourths. Now, if you wanted to spend the time to check, you could take this x value, negative 13 fourths, plug it in for x here, simplify, plug it in for x here, and simplify, and you'll end up with a true statement. These two values will be equal to one another. If we wanted to solve negative 3/5 x equals 18, the first thing you can do is you can divide both sides by that negative 3/5. So that negative 3/5 x divided by negative 3/5 equals 18 divided by negative 3/5. These negative 3/5 will cancel, and then when you divide by a fraction, it's the same thing as multiplying by its reciprocal. So we'll take that 18 times 5 over negative 3. That's really 18 over 1, and when you multiply fractions, you multiply their numerators, multiply their denominators, and then reduce. 90 divided by negative 3 gives us negative 30. There's another way to solve a problem like this. Look back at the original problem. Negative 3/5 x equals 18. This is really x over 1. So we can actually write that as a fraction and then multiply that negative 3 times x, that 5 times 1, and we get negative 3x over 5 equals 18. And now we can solve this in 2 steps. Get rid of this dividing by 5 by multiplying both sides by 5. Then we'll divide both sides by negative 3, and notice we get that same answer of negative 30. So the idea behind this is if you have a fraction in front of an x, you can just bring that x right up to the numerator. That will always work. So again, if you have a fraction in front of your x value, even if that was an x squared or an x cubed, this would still work. You can bring that x value right up into the numerator. Let's look at another example. 3x minus 5 over 4 plus 7 equals 2x plus 4 all over 3. Now, the majority of my students typically tell me that they don't like fractions. So if that's the case and you don't want to solve this by finding one big common denominator, that's fine. What you can do is you can actually do a little trick where you multiply everything by the largest denominator. So this is a denominator of 4. There isn't a denominator here, but we know it's really 1. And this is 3. So the largest denominator is 4. So what I'm going to do is I'm going to multiply everything, both sides, completely by 4. So here I will need to distribute the 4 to both of these terms. And here I'll have to, that's really 4 over 1, and that's just one term, so I'll multiply the numerators and multiply the denominators. Now when I multiply these two terms by 4, notice these 4's will cancel, and then I have 4 times 7, which is 28. And again here, that is really 4 over 1. So now I'm going to take 4 times the numerator, which I will need to distribute. That's 4 times the entire 2x plus 4. You can pretend there's a set of parentheses there. Over 1 times 3. And so when I do that, here's that 28 minus 5 gives me 23, and I get 8x plus 16 all over 3. So notice I got rid of this first fraction. Now I need to get rid of the second fraction, and we can do the same thing by multiplying everything by 3. Multiply the entire left-hand side and the entire right-hand side by 3. And so when I do that, I'll need to distribute the 3 here. Here, these 3's will cancel, and I have 9x plus 69 equals 8x plus 16. And now this is just a multi-step algebraic equation with variables on both sides. I can subtract 69 from both sides, and I get 9x equals 8x minus 53. Then I can subtract the 8x from both sides, and I end up with x equals negative 53. And at any point, if you want, you can plug in your solution into the original equation, plug in negative 53 for x here, and simplify. Plug in x equals negative 53 here and simplify, and these two values should simplify to the same answer, the same value. Let's look at another example. 33 minus x over 5x equals 2. Now this is different than the previous one because now we have a variable in the denominator. But you can still solve it the same way. If you ever want to get rid of a fraction, you can multiply everything by that denominator. So if I multiply both sides completely by that 5x, these 5x's will cancel, and I'm left with 33 minus x equals 2 times 5x, or 10x. So now you can subtract 33 and then subtract 10x if you want to, or I can just take this singular x here, add it to the other side, and I get 33 equals 11x, divide both sides by 11, and I get 3 equals x, which is the same thing as x equals 3 by the symmetric property. So now if you want to solve an algebraic equation that has more than one variable and you want to solve for one variable, you do the same thing. So here, if we want 5x minus 4y equals 12, we're trying to isolate y. Well, if this x wasn't here and it was just 5 minus 4y, we would subtract 5 from both sides. Well, we can do the same thing when there's an x. So what we'll do is we'll take that 5x and we'll subtract it from both sides. Now, the 12 and the 5x aren't like terms, so we just have to leave them separate. Now to get rid of this negative 4, to get y by itself, I'm going to divide both sides by negative 4. Now I'm dividing this entire side by negative 4, which means I need to divide the 12 by negative 4 and the negative 5x by negative 4. That 12 over negative 4 will reduce to a negative 3, and a negative over a negative will become a positive, or you can look at that as subtracting a negative is really adding, and that 5 over 4 stays as 5 over 4. Keep in mind, as we discussed just a couple minutes ago in this video, just like you can bring the x up to the numerator, you can bring the x down out of the numerator, and we can call that 5/4 x minus 3. We can switch those. This method right here, writing it like this, will become important in later exercises. Let's do one more. If we had y minus b over x minus a equals m, and we want to solve for y again, so again, looking at this, I want this y by itself. We have this big denominator here, so get rid of it the same way we had before. Multiply both sides completely by that x minus a. These x minus a's will cancel, and I have y minus b will be equal to that m times x minus a. We can distribute that m. Now to get y completely by itself, I'll just add b to both sides, and so you just get a funky answer. So if you have a bunch of variables in your example, in your equation, and you're trying to solve for one variable, that variable will be determined in terms of other variables. And sometimes it's funky and long and messy. That's it for now. See you next time.